I mentioned in the previous video very briefly that familiarizing yourself with the reactivity series will help you make sense of displacement and competition reactions. This is because the principle behind a displacement competition reaction is that a more reactive metal will displace a less reactive metal from a compound. You will have to know this, so I'm going to put a little bit of emphasis on this statement. Yeah, here we go. The reaction we're going to look at, which will prove this, is the thermite reaction, or the thermite reaction. Now, this process is used in railways when it comes to welding together the train tracks, and it requires a great amount of energy to get going. This energy is most commonly found from heat. It burns at a ridiculously high temperature, so it's an exothermic reaction. If you look at the iron oxide, which is highlighted in red, we can see that we get pure iron as a product, and aluminium then as its oxide. Recalling back to the reactivity series that I showed you, if you remember, the element of aluminium is more reactive than iron. Henceforth, iron is displaced from its oxide. What you can also note, if you recall back to me mentioning redox as well, which stands for reduction and oxidation, iron, or iron oxide, is reduced and aluminium is oxidized. Staying with the statement that a more reactive metal will displace a less reactive metal, we can also see this when a metal will react with another metal, salt. Salt, of course, being formed by the reaction between an acid and a base. Here we can see that magnesium reacts with copper sulfate, displacing copper from the reaction, leaving copper solid on its own and magnesium sulfate as an aqueous solution. Now, when this actually happens, you'll start with magnesium floating about in copper sulfate, and once the reaction is complete, they will completely swap over, and you'll be left with copper floating around and magnesium in the aqueous solution. The copper sulfate is blue, magnesium sulfate is colorless, and when crystallized you can see that copper sulfate is in fact very, very blue, and magnesium sulfate is completely clear. This is therefore evidence that the displacement reaction has in fact taken place. Now I'm going to discuss the process of redox. So two things to talk about, one being reduction, the other being oxidation. Firstly will be oxidation, secondly will be reduction. There are two ways to think about both of these processes, one in terms of oxygen, the other being in terms of electrons. There are going to be a lot of OX noises, I do apologise. So with oxygen, it is the gain of oxygen. Sorry, with oxidation, it is the gain of oxygen. Obviously, when something is oxidized, you can think of it as giving it oxygen. In terms of electrons, it's the loss of electrons. Reduction being the complete opposite of oxidation, as these reactions tend to happen simultaneously. Reduction is therefore the loss of oxygen. It's reducing the amount of oxygen it has. And in terms of electrons, the gain of electrons. I can never wrap my head around how reduction was the addition of something, so the gain of electrons. How I got past that was seeing how if something is reduced, because electrons have a negative charge, when something gains electrons, the charge reduces, it becomes more negative. We could put this into practice by looking at very specific reactions. So in terms of oxidation, we can see that copper here is oxidized. On the other hand, can also be reduced with the use of hydrogen, something which is slightly more reactive than copper. We can put redox into practice when we once again look at the thermite reaction. We can see that the iron oxide is reduced as the iron has lost its oxygen, and that aluminium is therefore oxidized. It's more reactive than the iron, so it displaces it, and aluminium becomes the oxide. Aluminium is therefore the reducing agent. As it itself is oxidized, that means that it must have caused reduction to have occurred. So aluminium is the reducing agent as it has reduced the iron oxide. Then obviously, iron oxide being the oxidizing agent, as it oxidizes the aluminium, and in turn the iron within the iron oxide is reduced. So this has been a summary of displacement and competition reactions, as well as looking at redox. We will look at another example in the next video when we discuss the extraction of iron. Thank you very much for watching.